Good morning, everybody. I am Lois George, a senior lecturer in mathematics education from the University of the West Indies, Mona campus in Jamaica. And my co-presenter is Alethia Martin, a secondary school mathematics teacher and a former graduate student. Our presentation focuses on exploring the secondary school students' attitudes towards mathematics through the lens of the ABC factor model. The presentation will proceed as follows. We will provide an overview, followed by the research gaps, the questions, the research designs and methods will be given. Then Alethia will present the results and discuss them a little bit, and then present the conclusion. So attitude towards mathematics is a multidimensional construct, and the ABC factor model captures this multidimensionality. In terms of the three factors that constitute this model, the affective component indicates the emotional aspect, that is how one feels about mathematics and engaging in mathematics related activities, while the behavioral speaks to how one behaves or when they are engaged in particular mathematical tasks. And the cognitive domain or component demonstrates the participants' confidence in their ability to study math. And while these components are unique, they are also interrelated and connected, which is a key focus of our presentation today. There are several gaps in literature which we are hoping to fill. For example, though the attitude towards mathematics construct is multidimensional, many studies and scales treat this unidimensionally. And Wayne and Dubé recommend that researchers of ATM should investigate how each subdimension uniquely and cumulatively contribute to mathematics achievement. Looking at the multidimensionality again of the ATM construct, Walker et al. Recommends and suggests that we should not just investigate attitude as a construct, but we should do so across varied ages, genders, and diverse samples. Finally, the different dimensions of students' attitude towards math could result in an individual and unique profile of a student, where a teacher or an educator could focus targeted interventions on areas that prove or show to be deficient. In terms of the research questions, we are adding to the empirical literature by focusing on what is the relationship between the components of students' attitudes towards mathematics and their math achievement, and what is the dominant component of students' attitude towards mathematics in general and by gender. So this research adopted a quantitative cross-sectional survey design involving 78 males and 43 female students aged 14 to 16 years. And we used an 11-item questionnaire adapted from Walker et al. 2020 to collect the ATM data. And then a teacher-made end-of-term mathematics examination was used to collect the math achievement data. I now hand over to my colleague Alethia, who will present the research findings.
Thank you. Good morning. It's a pleasure to be here. The findings showed that the association between the components of the students' attitude towards mathematics and their mathematics achievement was low, positive, and statistically significant. This means that as each component of the students' ATM increased, so did their mathematical achievement. The correlations were 0.354, 0.247, and 0.296 for the affective, behavioral, and cognitive components, respectively. The strongest association was observed in the affective domain. The affective component accounted for 12.5% of the variability of the students' mathematics achievement, while for the behavioral and the cognitive components, it was 6.1 and 8.8% respectively. The effect sizes obtained suggest that the results have little significance in practice. The relationship between the ATM cumulative and mathematics achievement was statistically significant with a correlation of 0.341 and a p-value of 0.001. The results also showed that 13.6% of the variance of the students' mathematics achievement can be significantly explained by the three predictors: affective, behavioral, and cognitive, collectively. Most existing studies report weak correlations between attitude towards mathematics and achievement in mathematics. These results were dependent on several variables, for example, grade, sample size, and ethnic background. However, we did not explore this component in our research. Future research, perhaps qualitative research, could focus on investigating the reasons or explanations for the correlation obtained. The association between each of the components of the students' attitude towards mathematics and their mathematics achievement in 4 studies revealed a low positive relationship. And these 4 studies we're looking at are Walker et al. 2020, Wan and Son, Mazzano et al. 2019, and our current study. Of the 4 studies, this current study and Mazzano et al. 2019 had affective component with the highest correlation coefficients, while Walker et al. 2020 and Wan and Son 2021 had the cognitive component with the highest correlation coefficient. Now, looking at the dominant component of the ATM, for our data, the cognitive component was a dominant component. The descriptive statistics test revealed that the mean was 4.09 and the standard deviation was 0.687 for the sample. The cognitive component is only the component that had the mean greater than 4.0. A mean greater than 4 means that the students were in strong agreement with most of the statements in the subscale. Despite having the highest mean score, the cognitive component had the lowest standard deviation, indicating that the data were close to the mean. A small standard deviation indicates that the data had less variation than the data in the sample. Now, by comparing the dominant component in 4 studies for our data, the cognitive component was a dominant component. Walker et al. 2020, who used the same questionnaire, also reported the cognitive component being dominant. Wan and Son 2021 and Mazzano et al. 2019 used different scales and found that the affective and behavioral components were dominant, respectively. Therefore, it would be that the scale affects the component is dominant. Also, the differences in the sample and our geographic locations may affect this. Being aware of which component is dominant will assist, if needed, in planning targeted interventions to improve different aspects of the student's ATM. This was a new dimension in the research domain. That is looking at the dominant component of the ATM by gender. Previous studies have generally explored the dominant component as shown in the previous slides. In Jamaica and the wider Caribbean, there has been significant gender differences in educational variables, such as achievement and mathematics anxiety. So exploring gender differences is important. The Manu test revealed that there was no significant difference as per gender in the cumulative students' attitude towards mathematics, or for each component of the student's attitude towards mathematics. For each of the components, females, as you can see, had a slightly higher mean for the ATM than males. The standard deviations were comparable. In conclusion, this research adds to the small number of studies that explore the multidimensional nature of the attitude towards mathematics construct. It provides the springboard for future research on this critical construct linked to the learner's academic performance, engagement, participation, and conceptual understanding. We thank you for listening.
Okay.